All right. A great day to one and all. I am Mr. Kim J.C. Ensho, a faculty member of Iloilo National High School SPSTE, and I will present to you exercises related to arithmetic sequences set 2. So I hope you are all set and ready for this. And if you are ready, let's go. Before we proceed further, we have to recall again the explicit form of an arithmetic sequence, which is a sub n equals a sub 1 plus n minus 1 times d, where a sub n here is the nth term of this arithmetic sequence, a sub 1 is the first term, n is the number of terms, and d is the common difference. Okay? So for this set, I will be giving you 5 items, and these are the 5 items. The first set was 1 to 5, so the second set is 6 to 10. So feel free to pause the video if you wish. Try solving the problems first on your own and verify if you got the correct answer or not. All right, let's discuss the solutions to these problems. Number 6. In an arithmetic sequence, the second and the eighth terms are 9 and 21, respectively. Find the common difference d and a sub 1. For the solution, it is important to note that a sub 2 is 9, a sub 8 is 21, and we will utilize the explicit formula, which is a sub n equals a sub 1 plus n minus 1 times d. Now, you could see that from the first given, a sub 2 is equal to 9. Remember that whatever the subscript of a, that will also be the value that of n here. So if we let n equals 2 and replace all n's by 2 here, we have a sub 2 equals a sub 1 plus 2 minus 1, or simply 1 times d, or d. But remember that the second term, which is equal to a sub 1 plus d, is equal to 9. Hence, a sub 2 could be expressed as a sub 1 plus d equals 9. I hope you got it. For the next given, a sub 8 equals 21. So the subscript here is 8. So if n is 8, then you will have a sub 8 equals a sub 1 plus 8 minus 1, or 7 times d, or 7d. And since the 8th term is 21, so a sub 1 plus 7d is equal to 21. And you could see now we have here systems of linear equations. And copying this one, you could actually perform elimination, because by subtraction, you could actually eliminate the a sub 1. So I copied the second one on top. So a sub 1 plus 7d equals 21. A sub 1 plus d equals 9. Then by subtracting, a sub 1 minus a sub 1 is 0. 7d minus d is 6d, equals 21 minus 9, which is 12. So in 6d equals 12, we will divide both sides by 6. And that gives us d as 2. Hence, the value of your common difference is 2. With d equals 2, we can now solve for the first term by substituting d equals 2 either to the first or to the second equations here. In my case, I chose a sub 1 plus d equals 9. So substituting d equals 2 in a sub 1 plus d equals 9, you have a sub 1 plus 2 equals 9, minus 2 both sides gives you a sub 1 equals 7. Hence, the common difference is 2, And the first term of this arithmetic sequence is 7. I hope you got it. Number 7. In an arithmetic sequence, the third term is 13 and a sub 9 equals 37. Find D, a sub 1, and a sub 20. So if you could notice, the format of this is kind of similar to number 6. It's just that we are looking for the value of a sub 20 as an additional requirement. So the same thing, it's given that a sub 3 is 13 and a sub 9 is 37. And using the explicit formula and letting the subscript n be 3, you will have a sub 3 equals a sub 1 plus 3 minus 1 or 2d, which is 13. Then with a equals 9, with n equals 9, you will have to replace all n's by 9. So you will have a sub 9 equals a sub 1 plus 9 minus 1 or 8 times d or 8d. But the 9th term is 37. That's why I have a sub 1 plus 8d equals 37. And so again, we have systems of linear equations. We could subtract the second equation here by the first. And the a sub 1's will cancel. The 8d minus 2d will become 6d. The 37 minus 13 is 24. So 6d equals 24. Dividing both sides by 6 gives d equals 4. Now that we have d equals 4, we can now solve for the value of a. In my case, I chose to substitute d equals 4 with a sub 1 plus 2d equals 13. So replacing d with 4, we have a sub 1 plus 2 times 4 equals 13. 2 times 4 is 8, and 13 minus 8 will give you 5. So the first term of this sequence is 5. Now that you have the first term and the common difference, it is now possible to determine the 20th term of this sequence. To do such, we will substitute again to this explicit form, but since we will be solving for a sub 20, we will let n be equal to 20. With that, we have a sub 20 equals 5 plus 20 minus 1 times 4. 20 minus 1 is 19, so 19 times 4 is 76. So a sub 20 is 5 plus 76, or 81. So if you list all of the terms here, or if you list some of the terms, expect that the 20th number that you will list from left to right will be 81. I hope it's clear. Number 8. Find all the unknown terms in the arithmetic sequence a sub 1, a sub 2, a sub 3, a sub 4, 28, a sub 6, a sub 7, a sub 8, 48. So what do you think are these values? So you're looking for 7 values here. And is it possible to determine the values? Yes. And how? We'll see. So for the solution of this, you could actually see that 28 is the 5th term. And because it is the 5th number from the left. And 48 is the 9th term because it is the 9th number from the right. So it's quite similar again to the process we had for number 6 and 7. So by utilizing the explicit formula, letting n equals 5, we will have a sub 5 equals a sub 1 plus 4d, but a sub 5 is 28, so equals 28. With n equals 9, you will have a sub 9 equals a sub 1 plus 9 minus 1, or simply 8 times d or 8d. But the 9th term is 48, so a sub 1 plus 8d is equated with 48. So subtracting again the second by the first equations, the a sub 1 becomes 0. 8d minus 4d is 4d. 48 minus 28 is 20. Dividing both sides by 5, that gives you the common difference of d equals 5. From here, we could substitute d equals 5 either to the first or the second equation. I chose to substitute it on the first equation. That's a sub 1 plus 4d equals 28. So d is 5, so a sub 1 plus 4 times 5 equals 28. 4 times 5 is 20. And you have 28 minus 20 as the value of a sub 1. Hence, a sub 1 is 8. And since we know that a sub 1 is 8, it is now possible to determine the values of the other terms. From here, knowing that a sub 1 is 8 and d equals 5, and these are the missing terms. So a sub 1 is 8 there. And recursively speaking, you have to add the common difference to get the next term. So 8 plus 5 will be 13. 13 plus 5, 18. 18 plus 5, 23. 23 plus 5, you see, it's 28. So it's okay. Then you have 28 plus 5, 33, plus 5, 38, plus 5, 43. If you try to add 5, 43 plus 5 will be 48 indeed, which is your last term. That's why you could see each of these numbers will make an arithmetic sequence. So therefore, the values of the missing terms that I presented here are hereby correct. All right. I hope you got it. Number 9. If x plus 6, 2x plus 1, and 4x minus 13 are the first three terms of an arithmetic sequence, find x, a sub 1, d, and a sub 11. So it's asking for a lot. So you might be trying or doing trial and error to determine the value of x, but that might give you a long time. That's why before we solve this problem, I will actually be deriving the formula first. Suppose a sub 1, a sub 2, and a sub 3 are the first three terms of an arithmetic sequence. Remember that in an arithmetic sequence, if you subtract the second by the first, it's equal to a sub to the third minus the second. In fact, you have your common difference in this case. That's why you have a sub 2 minus a sub 1 equals a sub 3 minus a sub 2. Adding both sides by a sub 2 and adding both sides by a sub 1 as well, you get a sub 2 plus a sub 2 equals a sub 3 plus a sub 1. And adding the left side, we have 2a sub 1, 2a sub 2. And rearranging the terms on the right-hand side, we have a sub 1 plus a sub 3. That is why we have 2 if the terms a sub 1, a sub 2, a sub 3 are the three terms that form an arithmetic sequence, then expect that twice the middle number is or twice the second or twice the middle number is equal to the sum of the first and the last terms of your arithmetic sequence. Or it's just first plus third term for this case. So using this idea now, we know that the first term is your a sub 1 is x plus 6, your a sub 2 is 2x plus 1, and your a sub 3 is 4x minus 13. With that, twice of 2x plus 1 is equal to the first term x plus 6, added by the third term 4x minus 13. Simplifying the left-hand side, 2 times 2x plus 1, it's 4x plus 2. equals the sum of the right-hand side, which is 5x minus 7. Subtracting both sides by 5x and adding both sides by -2, you will have 4x minus 5x equals -7 minus 2. The left-hand side simplifies to -x, and the right-hand side simplifies to -9. Multiplying both sides by -1 gives us x equals 9. Hence, x must be 9 so that this sequence will be the first three terms of the first the sequence defined by these first three terms will be arithmetic. And you might ask, if x equals 9, let's see if this is correct. Let's substitute all x's by 9s and simplify. 9 plus 6 will be 15. Okay, so that's your first term. 2 times 9, that's 18. Plus 1, that's 19. 19 as your second term. 4 times 9, 36. 36 minus 13 is 23 as your third term. If you could see, 19 minus 15, it's 4. 23 minus 19, it's also 4. So you have a common difference. So this is indeed arithmetic. You could see here that the first term is 15 and that the common difference is 4 based on what I mentioned earlier. And also, since we have the first term and the common difference, it's now possible to solve for the 11th term using the explicit formula. So a sub 11 will be equal to the first term 15 plus number of terms minus 1, 11 minus 1, times the common difference, which is 4. So with such, 11 minus 1 is 10, times 4 will be 40. That's why 15 will be added by 40. And the 11th term, therefore, of this sequence is 55. I hope you got it as well. Number 10. Three numbers are in the ratio 6:7:9. If 2 is added to the second number, it means this means to say that the other numbers are untouched. The three numbers will form an arithmetic sequence. Find the numbers. So when I say find the numbers, find the original numbers that are in the ratio 6:7:9. Okay? So for the solution of this, we don't know yet what the numbers are. But so we will let x be the GCF of the three numbers. GCF stands for the greatest common factor, because you could represent the three original numbers as 6x, 7x, and 9x, because if you will divide each of this by x, you will go back to your original ratio, provided that x is not equal to 0 and x is a real number for this case. So these are the three original numbers. And you will add 2 to the second term, so which is 7x, and you add 2 to it, it will become 7x plus 2. So the new sequence, if that happens, you will arrive to the new sequence, which is 6x, 7x plus 2, and 9x. And utilizing again the formula or the concept in number 9, twice the middle number, so twice of 7x plus 2, is equal to the sum of the first and the third, so 6x plus 9x. Multiplying the left-hand side, that gives you 14x plus 4, because that's the product of these two, equals 6x plus 9x, which is 15x. And from here, I subtracted both sides by 14x, so 4 is equal to x. All right. If x is 4 for this case, you could see that the original numbers, we are looking for the original numbers, by the way. So we have to multiply 4 to each of 6, 7, and 9. and multiplying, okay, 4 times 6 will 6 times 4 will be 24, 7 times 4 will be 28, 9 times 4 will be 36. All right? And remember, this is not an arithmetic sequence, right? But if we would check, if we will add 2 to the second number, this 28 here will become 30, and the rest will become, are still the same. So you will arrive to the new sequence 24, 30, 36. Indeed, you could see that 30 minus 24 is 6. 36 minus 30 is 6. So you have a common difference of 6 for this case. And remember, we are looking for the 3 original numbers. So your final answer for number 10 should be 24, 28, and 36. I hope you got these numbers correctly. And before we end, let's have our quote for the day. Forget the mistake, but remember the lesson. With that, thank you very much and a great day to one and all.